Problem 6 says if the length of a rectangle is decreased by 5.2 centimeters and its width is increased by 1.5 centimeters, then the area of the rectangle will decrease by 7.5 centimeters squared. However, if the length is increased by 6.2 and the width is decreased by 0.5, then the area increases by 16.9 centimeters squared. Then it asks us to find the length and width of the rectangle. So we know that our equation for the area of a rectangle can be written as A for the area equals L for the length times W for the width. Then we can come up with some other equations for what happens when the length and width change for this rectangle. So first one I'm going to write is if the length is decreased by 5.2 centimeters, I'm just going to leave the centimeters, the units out of these equations to make them easier to work with, but we'll remember that these units are there when we get the answers. So length decreases by 5.2, and the width increases by 1.5. So now I'm multiplying my new length and width. This gives me an area that decreases by 7.5. And then for the other part of this problem, when the length increases by 6.2 and the width decreases by 0.5, this gives us an area that's increased by 16.9. So I'm just going to draw a little line here to make sure we know that these are separate. I'm going to start with this equation on the left, and what I want to do with it is the first thing I want to do is plug in what we know about the area. We know that the area A is equal to L times W, so I can plug in L times W for A here. And the other thing I want to do is multiply these brackets out. So on the left side here, this gives me L times W, L times 1.5, so that's plus 1.5 L, negative 5.2 times W, it's negative 5.2 W, negative 5.2 times 1.5 is negative 7.8. And for the area, I'm plugging in L times W, and I have this negative 7.5 out here. So we can see that on the left side of our equation, we have L times W, and on the right side, we also have L times W. So these just cancel out. You can get rid of them. It would be the same as subtracting L times W on both sides, and you can see that they'd cancel out. And so I'm going to rewrite what I'm left with, which is 1.5 L minus 5.2 W minus 7.8 equals negative 7.5. So the next thing I want to do is add 7.8 to both sides of my equation. And what I'm left with is 1.5 times L minus 5.2 times W equals negative 7.5 plus 7.8 is 0.3. And so what I want to do now is get one of my variables in terms of the other. And I'm going to do this by adding my W term onto the other side. You can do this the other way around and solve for W2. Either way will work. It's the same process. So this gives me 1.5 L equals 0.3 plus 5.2 W. And now I'm going to divide by 1.5 on both sides of my equation. And this gives me L is equal to this term here, which I'm just going to rewrite, 0.3 plus 5.2 W over 1.5. So now I have my variable L in terms of W. And what I can do is plug this in for L in this equation here. But this is a bit messy, so what I'm going to do first with this equation on the right is rewrite it a bit to make it a little bit neater. And I'm going to do the same thing I did for this first equation. I'm going to multiply out these parentheses. This gives me L times W for that first bit, and then L times negative 0.5 is negative 0.5 L. 6.2 times W is 6.2 W. And a positive 6.2 times a negative 0.5 is negative 3.1. Then again, I'm going to substitute L times W for A here. And I still have the 16.9 on the outside. And again, I have L times W on both sides of my equation, so I can cancel that out. And I'm going to rewrite what I'm left with, which is negative 0.5 L plus 6.2 W minus 3.1 equals 16.9. And I'm going to add this 3.1 to both sides of my equation next. This gives me negative 0.5 L plus 6.2 W equals 16.9 plus 3.1 is 20. So now I have a little bit of a simpler equation here, and like I said earlier, what I want to do is plug in this term for L into this equation here. So this is going to give me negative 0.5 times 0.3 plus 5.2 W all over 1.5. And since I'm multiplying this, it's okay to just put it on the top of my fraction. And still have this plus 6.2 W here, and that equals 20. So the next thing I want to do is get rid of this ugly fraction here. And the way I do that is by multiplying both sides of my equation by 1.5. So hopefully this isn't too messy here. What I'm doing is multiplying this side by 1.5 and this side by 1.5. Sorry, those aren't exponents, they're multiplications. Just ran out of room here a bit. So multiplying this 1.5 in to this first term just gets rid of the 1.5 on the bottom. And what I'm left with is negative 0.5 times 0.3 plus 5.2 W. And then 1.5 times 6.2 W is 9.3 W. And 1.5 times 20 is 30. So we can see now we've gotten rid of our fraction here. And what I want to do next is multiply the 0.5 into the brackets, and that gives me 0.5 times 0.3, sorry, negative 0.5 times 0.3 is negative 0.15. Negative 0.5 times 5.2 is negative 2.6 W. I still have this 9.3 W on the outside, and that equals 30. So then combining my terms with W in it gives me negative 0.15. Negative 2.6 W plus 9.3 W is positive 6.7 W. That equals 30. I'm going to add 0.15 to both sides of my equation. That gives me 6.7 W equals 30.15. Now dividing by 6.7 on both sides of my equation, I get W equals 30.15 divided by 6.7 is 4.5. And remember that all our terms here are in units of centimeters, so this is 4.5 centimeters equals W, which is my width of my rectangle. And the last step is to just plug in this value for W into this equation here that we have for L. And doing that gives me L equals 0.3 plus 5.2 times 4.5 over 1.5, which is equal to 0.3 plus 5.2 times 4.5 is 23.4. So all over 1.5. That gives me on the top 23.7 over 1.5, and dividing that out gives me 15.8. So again, that's in centimeters, so 15.8 is equal to L, our length. So those are our values for the length and width of the rectangle.